Good afternoon, everybody. My name is Pat Telford. I'm part of the Azure Stack Early Adoption Program, and I'm going to be talking to you today about the Azure Stack patch and update cycle. So here's what we're going to talk about. We'll first go through the servicing policy, so when you need to update Azure Stack. We'll talk about the format of the updates, how the actual update occurs, so the flow of the updates, what you would do as an operator to trigger and administer those updates, and what to troubleshoot if things go wrong during. So have an overview. So really, as an Azure Stack operator, you want to understand how you can deliver Azure services in your data center with Azure Stack and avoid disruptions to the users, the people that are running workloads in your Azure Stacks. So how do you know what to install? What's the process for it? What are the tools? If anything goes wrong, what do you do? What's the difference between updating the software part of Azure Stack, where the software comes from Microsoft, and the other hardware related pieces like firmware, drivers, the switch operating system and firmware, those sorts of things that are part of the hardware bundle of Azure Stack. So we'll talk about how those all work, and critically, the patch and update cycle, especially for a large instance of Azure Stack with a lot of server nodes, the update can take a long time, and you'll see why. I'll explain the engineering of it in a little bit. So the general philosophy for updates in Azure Stack is not patch, patch, patch. Any of you that are familiar with operating Windows servers or any other kinds of servers in the data center, if they've been running for a long time, you've normally been applying patch after patch, month after month. So it's like a long layer of individual software updates that apply to each server. And occasionally things will go wrong. So you'll end up with a server estate that has been patched slightly differently. Each one is a little bit unique. So that's not the philosophy for Azure Stack. In Azure Stack, the idea is that every server node's operating system, and remember the server nodes are running Windows Server 2016 under the covers, each virtual machine that's running as part of the fabric, all of those things won't be patched month to month. They will be wiped and reloaded with a brand new copy of the operating system with all the patches bang up to date for that month, and then the configuration will be snapped back on top of those. So it's a different philosophy than you might be used to in the server and workstation patching world. The other thing is it's designed to be driven through an operator process. So likely by an operator logging into the operator portal and performing some tasks to obtain the monthly update and to apply it to the running Azure Stack. And during that process, a lot of care is taken to make sure that both the fabric of Azure Stack stays up and running and all of the virtual machines that are powering the workloads running on there, whether they be infrastructure as a service or platform as a service, things like websites, databases, etc. The care is taken to keep them running throughout the whole process. You'll see how that works shortly. So what's the servicing policy for Azure Stack? How often do you have to patch? How much do you have to stay up to date? So the general servicing policy is that you must keep your Azure Stack within striking distance of the current release. So that means 2 versions. If you stray beyond that, so if you're 3 versions behind the current release of Azure Stack, you're technically not supported. And from a Microsoft perspective, not supported means that when you call up for support, we're not just going to hang up the phone on you. We will take some steps to try and troubleshoot your problem. If the troubleshooting is getting too involved, we will ask you to update your Azure Stack or whatever software you're calling in to a currently supported version, and then we'll continue with the troubleshooting effort. And obviously, if you're having trouble in the update cycle itself, we're going to continue to help you until you can get updated to a supported version. So basically, keep in mind you're expected to stay within 2 releases of the currently released version of Azure Stack. So here's a little table that shows, for example, how you might move from version to version for update. So if you look in the table, for example, if you start at 1710, you're going to move to 1711 to 1712 to 1802, 1803, 1804. And you'll see that each release is given a number. That's the 2-digit year followed by the 2-digit month that the update is released in. So the version of Azure Stack is released in. One critical thing to understand here is that the updates are non-cumulative. So if you're 3 versions behind, you're going to have to go through 3 patch and update cycles to get current. There's good reasons for that. The primary engineering reason behind that is that we never test updating directly from a version that's 3 versions behind to the current version, or 4 versions behind to the current version. And as you can imagine, if we did test all those, they may well work, but if we did test those, the test matrix is going to get bigger and bigger and bigger every single month. So the engineering processes that we have conjoined with our hardware partners are that we will move one step at a time and fully test that update process, and we expect the customers to follow suit. It's also possible that with some changes, like some version change to another, there might be some prerequisites or some sort of configuration change that you need to make. For example, one of the releases earlier this year, there was a change to the way that certificates were handled. So there was some homework to do to prepare your configuration for that particular move. So obviously, if you jumped over that release, or if you were allowed to jump over that release, you might have missed out on a whole set of steps to keep the configuration of your Azure Stack sound. So that's the main reason why you're expected to move one step. Now, what's involved in delivering an update? This isn't super crucial. You don't need to know how this works as an operator. The updates will just come down and you'll apply them. But it helps from an architectural perspective for you to envision what's going on behind the scenes. So there's 2 types of updates that might come down, or 2 streams. There are the Microsoft updates. So those are software updates to the Windows operating system that's running on the server nodes of Azure Stack. Updates to the Windows operating system that's powering the virtual machines that run the fabric of Azure Stack. So all those little virtual machines that are running inside Azure Stack. And then updates to the Azure Stack specific software. So all those resource providers, all the software that's running on the virtual machines that are powering the fabric, those things are updated over time. So not just security patches might arrive in an update. There might be functional updates, fixes to the Azure Stack software itself, portal changes, all those types of things. So all that is Microsoft update. That's all one category of update. The second category is updates that need to come from the OEM that provided your Azure Stack. So those might be things to the firmware for one of the devices in the servers. There might be updates to the operating system for the top of rack switches. There might be configuration changes for the switch. All those things are OEM specific, and they will come through a different update from each OEM specifically. They may well be integrated in the way that you obtain them and apply them, but just keep in mind that they come from 2 separate sources. The updates themselves are deployed through Azure Stack. So the Microsoft updates, they'll appear in the portal. Recently, there's been capability added to Azure Stack to be able to see the OEM updates as well. Previously, you would have to go onto the special extra machine, the hardware lifecycle host, the extra server that's in the rack of Azure Stack, and apply them by following some instructions from the OEM. So we're getting better at integrating those patches. So I think I've gone over this. The OEMs are responsible for the firmware, the drivers, the switch configuration, anything like that. They might also send updates to their own management software. Some of the OEMs have their own branded management software running on that hardware lifecycle host. And Microsoft is responsible for everything in Windows and all the core software for. Generally, we will release 1 update per month. Not every month has updates, but most months do. So you'll see occasionally we might skip a month and just provide an update the following month. So you don't need to stay within 3 months of the current version of Azure Stack. You need to stay within 3 releases. Sometimes that might be 4 or maybe even 5 months. And occasionally we'll issue a hotfix. So a hotfix will be a functional fix or something really critical that we feel we have to resolve in the current version of Azure Stack. And it's more like a traditional patch. It's not going to rip and replace the operating system on Azure Stack. It's going to just send a software patch to whatever part of the system needs to be patched. The server hosts, one of the virtual machines in the fabric, something like that. So keep in mind that there might be these little interjecting patches that come from time to time. The OEM updates may come at different times. So I'm not going to go into that here because each OEM is different, but the OEMs will have a different way of communicating with you and possibly a different cadence for their release. Generally, though, if you remember that we do co-engineering with the OEMs, so they test on a monthly basis, and I'll show you that process in a couple of minutes. So their releases tend to come aligned with one of the monthly releases for Azure. I mentioned the package versioning, so the package will have a long number. So for example, here the September 2018 release is 1.1809 for September of 2018, .0.90. And then the first hotfix, if there was one for that build, would be 1.1809.1.x, etc. So that's the detailed version number. The simple version number is just 1809. Whenever you hear someone refer to a version of Azure Stack, they'll call it 1809. That's the September 20 release. Inside the package, there's some stuff, and you don't really need to know this at all, but it is just like a Windows software update. So there will be a self-extracting package name. So it'll be a really large file. You can see here this one is 2 gig in size. This is one big file. There's an installer, so the executable file, and then there's a metadata file that contains information about the update, any prerequisites, etc. inside the package. And the XML file contains some information. So you can see here's some sample metadata for the 1809 update. So it's got its name in there. It's got the full version. It says the package size is going to be 2.3 gig. It's got a description. It's got a link to the bulletin for that release. You should always read the release notes because there's often things in there like maybe some prerequisite steps, etc. So this is the bundle. It's an XML file. It's an installer executable, and then it's a giant file of data. So if we put all that together, you can imagine the green row here are the Azure Stack updates. So 1712 followed by 1802. You notice there's no 1801 in here because that was a month that we skipped. In between there, a hotfix came out. So you can see that's a hotfix to the 1803 version. And there might be some post-update hotfixes as well. Those are the ones in orange. Also, the resource providers. So right now we have the app services resource provider for websites, functions, etc. And we have the SQL and MySQL resource provider. Those updates are released separately. So they don't come on the same monthly cadence. They normally get released every few months or so as they add features and hotfixes to those. So you have to keep a separate eye out for the releases for this resource provider. So this is a good thing to understand is how we as Microsoft and our team of OEM partners produce the updates and deliver them. So if you can imagine, developers inside Microsoft and at the OEM are working on updates to the Microsoft stack, firmware, etc. So we build that, we test it, we do unit testing, we deploy and validate that on some internal Azure Stack systems within Microsoft until we're confident that it's sufficient quality to be released. We then have a validation pass still internally at Microsoft, and we run that on a bunch of multi-node Azure Stack systems. So this is to make sure that we think it's going to run on all the vendors' hardware stacks that are out there. Then we pass the update to the partners. When we give it to the partner, they each test on their test systems for Azure Stack. So they might test on their all-flash system. They might test on their big system, their small system. But eventually they're going to either report bugs back to us, which we'll fix, and we'll go through the cycle again, or until they're confident of the delivery. And then there are some long haul, some self-hosting environments that are out there. So once the partners have all tested, we test the release on all the partners' hardware sets. And only at that point, if there's no bugs, if the software is of sufficient quality, will we do a release. And then it will go out to customers. You'll see it appear in the Azure Stack portal. So you can see this is why sometimes we might skip a month. If there were bugs found, especially if they're found late in that process, then we wouldn't release. So we need to release in conjunction with all of our OEM partners, and all of us have to be confident that it's a quality release. Here's how the update works. So you've got this bundle of information. You select which update you want to download. It pulls the bits down, and that update will get stored into blob storage on the disks inside Azure Stack. So the portal will trigger the download, and it will sit it somewhere in a shared part of storage. And then once it's downloaded, you will kick it off. So this is the engineering marvel that makes sure that you keep a consistent base, a consistent installation of Azure Stack from month to month. As I said before, it's not patching individual servers, it's wiping servers and replacing them with a brand new image and then restoring its configuration. After that, we do the same thing to all the virtual machines that run the fabric of Azure Stack. So they are all wiped, reloaded, replaced with their current configuration. So if you imagine here, we have a 4-node Azure Stack. So the 4 servers are shown across the bottom. They're all booting from a virtual hard disk that's sitting on the physical disk on one of the disks attached to each server. Those little blocks on top are the virtual machines that are running on top. The blue blocks are the fabric virtual machines, so the virtual machines that run the portal, all the resource providers, everything that's required to operate Azure Stack, and the green ones are user workloads. So if in this picture, you as an operator have triggered the patch and update cycle, here's what happens. First of all, a new VHD is plopped down. So that new VHD has Windows Server 2016 with the up-to-date security patches, because we're not patching the existing OS, we're just putting down a new image. So we slap down a new VHD onto each server host. Then we're going to prepare to act on server 1. And this all happens, this is all automated, happens under the covers. So we do live migration of the user workload VMs, IaaS or PaaS, and any of the fabric VMs that are running on that server node. So now that server is evacuated. That evacuation will take a shorter or longer time depending on how loaded your Azure Stack instance is. But now this server is essentially unneeded to run Azure Stack. This is why we always have a 1-node reserve of capacity that you're not allowed to consume as an Azure Stack operator or user. So all the workloads have been run off. There's enough capacity. We guarantee there's enough capacity to run on the other 3 nodes. Then we tell server 1 to boot from the other VHD. So it's a fresh VHD for this month. It's not configured fully. So we take a configuration that we've set aside in the resource providers and we apply it to that server host node. At this point, that server is now running the current month's version of Windows Server. It's bang up to date. It's now eligible as a target. It's back in the cluster with the other server nodes. Workloads can be shuffled over onto it. We do each of the server nodes in turn like this until all nodes in the Azure Stack have an updated operating system. After that, we need to update the fabric VMs. So those dark blue VMs here need to be updated. So we do a similar thing. Those VMs are clustered, so they're guest clustered with each other. So it's okay for us to take down one of a pair at a time, wipe it, reload the operating system into that virtual machine, plop the configuration for whatever service it's running. If it's the storage resource provider, we put the storage resource provider configuration back onto it, and then we recluster it with its mate. Then we would go to the second pair of that clustered VM, and we do the same thing to it. We break the cluster, leave the now updated one running, wipe and reload the operating system on that virtual machine, send the configuration back onto it, and then recluster it with its pair. So that whole process will patch each VM in turn. But again, it's not a patch, it's a wipe and load. And the whole fabric will stay running. All the guest workloads will stay running as we go through. So you can see, once that process is complete, we've now applied a new image to every server and a new image to every running VM that's part of the fabric. The IaaS virtual machines, the user workloads, we do not touch in this process. It would be like normal IaaS. The users would be responsible for patching and uploading or upgrading the operating system on those ones. So one interesting thing to think about here is this is how we abstract Windows Server from Azure Stack. So you don't need to know that Windows Server is running underneath Azure Stack on those server host nodes or in the VMs. And if you imagine when we want to move to Windows Server 2019 as the foundation for Azure Stack, that's going to work just fine. We're going to plop down the new VHD for each server host. It's going to be Server 2019. We'll boot it up. We'll add it into the cluster. So all server nodes can be clustered. Only one will be Server 2019 at the start, and the rest will be 2016. But that's okay because we can have mixed OS clusters in Windows Server now. And eventually all the servers will be brought up in Server 2019. We can do the same thing with the Fabric VMs. So this is like a marvel of engineering, all to hide the patch and update cycle from you as an operating stack. Now, I said it was a marvel. This process can take a long time. So this graph here is for hot fixes. So this is really just patching individual server nodes and individual VMs. So you can see it takes some minutes. This is some real data for the time taken to apply a hotfix to a Azure Stack scale unit. The times will depend on how many nodes are included in your particular Azure Stack system. Now the updates, here's some sample times in hours for an update to apply. So you can see the updates are getting slightly bigger over time, and we've gotten up to 35 hours plus to apply an update and wave it across a whole 12 node Azure Stack system. So it's a considerable amount of time. We've been doing work on the patch and update cycle continuously since the release of Azure Stack. Priority number one was to make it more reliable, because we had a lot of customers had failures in the middle, or they had trouble getting from one version to another. And then the other activity was to try and make the update cycle shorter. So we recommend that during the patch and update cycle, although the fabric should stay up, and although the workloads, the user workloads should stay running, that you do not allow any new workloads to be added to Azure Stack during that time. Although we recommend that you don't create any virtual machines during this time, it all should work. The danger is that as we're updating individual VMs that are part of the fabric, we're in a no fault tolerance state there. So something could go wrong. If that second VM that's been clustered together goes down while we're updating the first one, problems might arise. So it's really just a caution to be careful during the patch and update cycle. There's no switch in the portal or anything that we have that can turn on to prevent people from creating a new workload, from adding VMs during this time. But some people do some little tricks to work around this. So you can use the DNS name of your portal and repoint it to another page that just says, hey, we're in maintenance. We expect to be back at such and such a time. So point them away from the portal. You could change the quotas on people's offers and plans so that they're unable to create any new workloads during this time. Or some customers just leave it running. So there's nothing practical to stop the users from creating a new VM or adding to their workload. But you just notify them that we're in a maintenance period and something could go wrong during the creation of a new VM. So that's just a note of caution. Although the engineering of the solution is such that all the workloads and all the fabric should stay running, the fabric is in a little bit of a precarious state during this activity. So as an operator, what do you need to do during the patch and update cycle? So there's a couple of variations here. One is a connected experience. So in the connected experience, the portal will detect that there are new updates available, and they will automatically show up once they're there. You don't have to perform a manual download. If you're disconnected though, and you don't have connection to the internet, you're obviously not going to get any notification that the updates are available. You would have to watch for that. And there is a way to download the updates separately, like onto a workstation, and bring them across SneakerNet to a disconnected Azure stack. We'll go through how that process works shortly. So here's what you do to download the update packages if you're disconnected, or if you want to do them out of band. Let's say your bandwidth is sensitive. You can still do this on a connected Azure stack. So there's an Azure Stack downloader, an update downloader. So you get that tool, you put it on a workstation, you run it up. It will tell you which updates are available. You select them and you download them. So you'll pull them on the workstation. You'll notice after you download an update package, you will have to update it into your Azure Stack environment. So you're basically going to copy the files from the download into a storage account, into blob storage on the Azure Stack. And only once they're there will the portal recognize that there's updates available, and then you can apply them in the normal fashion. So you're going to create a storage account, new updates. Once you copy them across, you'll see that the updates are available in the operator portal. So the square on the left is the block in the dashboard of Azure Stack that you'd see that says an update's available. You can click on it and you'll be taken to the screen. It will show you all the updates that are potentially available for you. Then you can click on them. So you can filter which updates you want to take a look at. You're going to have your disconnected copy. You're going to select a storage to copy it to, and you're going to create a container in there. So you give the container a name, and then once it's created on the Azure Stack side, you'll upload the packages from your workstation or your disconnected, wherever you copied the download package from, and you're going to upload the blob into that. So once the data is uploaded there, you're going to repeat that for the 3 files that are part of the package. And then you'll see in the portal that there'll be a notification saying, hey, the update. You can go back to the dashboard and you'll see the update tile. It should now say that an update package is available. And then you'll follow the normal process. So all of those steps there were for a disconnected scenario. If you're connected, you're just going to see in the dashboard that an update is available because it will be talking to Azure. It will see the update, it will download it and prepare it for you. So once you have the update there, either online or disconnected, you'll click the update panel. You'll select the package that's ready to be installed. And then you can use the update now action at the top. I'll show you where that is in a second. You can watch the progress of the update through the normal top right-hand corner part of the operator portal that shows what things are running. And when the update is completed, the update tile will show the new Azure Stack version, 1908, etc. Of course, everything in Azure Stack you can do in the portal, you can also do in PowerShell. So it's a really simple process to kick off the update. You just use the install AZS update PowerShell cmdlet, and you feed it the version number. If you want to see the version number of a running Azure Stack, you just use the get AZS update cmdlet. So here's what it looks like in the portal. From the dashboard, there's the update tile. It says that updates are available. You're going to click on that. You go in here. You can see in this example screenshot here, there were 3 updates available. Some of them, these ones are already installed. If there are updates available that are not installed, you can click that Update Now button and it will kick off the process. So because you might want to have your servicing window happen overnight, that's when you might want the PowerShell script, right? So you might go in here, check and see which updates are available, and then have a scheduled PowerShell script that's going to connect to your Azure Stack instance and run that Azure Stack update trigger command with the proper version number. And that could start at whatever, midnight or something. It's going to run for a long time. So the idea of a typical service window of being a few hours overnight isn't really going to apply here because it's going to run for more than a day. Sometimes the updates can fail in the middle. You have the ability to retry them, right? So there might have just been one step failed because of a temporary failure. So you don't really want to roll back if you've already patched 15 of your 16 server nodes. So you can try and resume where it left off. Again, there's a PowerShell command for it, and you can retry as many times as you want. It's possible there might have to be some intervention to fix up something that went wrong. So this would be the time to open a support case with Microsoft and do some troubleshooting of the update process. You can also watch and see what's going on in the update process as it's occurring. So you can get to the privileged endpoint. So that's the PowerShell accessible function that's running inside the Azure Stack. And there are some CMDlets in there. So you can look at the Azure Stack update status in there, or you can kick off the resume function just like you would do in the portal. So those are from the privileged endpoint that you would log on with your cloud admin account. So one thing to note here is if the update is unsuccessful, you can fully roll back. So remember that picture before I showed you that we don't just blow away the operating system on the server nodes. We plop down another virtual hard disk beside the original one, and then we just repoint and tell the server to boot from it. So it's possible to roll back to the previous one. The same thing is true for the Fabric virtual machines. We plop down a VHD for each Fabric virtual machine, and we repoint the VM to use that instead of its old one. If the update is successful, we tidy up all of those leftover rollback VHDs when we're finished. But if the update fails in the middle, it's smart enough to be able to retrace its steps and go back to the previous VHDs for all the Fabric VMs and all the server nodes one at a time in the sort of reverse order that it started, with the evacuation of those nodes happening all behind the scenes. So it's technically possible that you might have an update that takes 40 hours to finish. You could get to hour 39 and then decide, oh, I want to roll back. It would then take roughly 39 hours to roll back and replace all those VHDs with their originals. But it's very orderly and very possible to do that. So another thing to point out here on the PowerShell side is that the Azure Stack tools, PowerShell CMDlets, have a few tools to manage the update process for you. So you can find the location of the update status. So you can use get AZS update location, and you can look at the summary of the update logs that have been stored in that location. You can retrieve the list of Azure Stack updates that are available on your system. You can install a particular update, and you can validate a previous update run if you want. So you can look at the logs or see what happened during the update. Again, all this stuff is available both through PowerShell, and most of the PowerShell things are available in the portal. So just to recap, the updates for Azure Stack come once a month, normally, in the fourth Tuesday of the month, and they're referred to by a 4-digit number, 2 digits for the year, 2 digits for the month. So 1808 is our example here. We support you if your Azure Stack is running the currently released version or any of the 2 previous releases. If you go to 3 releases behind, you're technically not supported, and you may be asked to move up to a current version of Azure Stack before we continue supporting if we get a particularly thorny case. The updates are both security fixes to the operating system, to the Fabric VMs, as well as functional fixes and functional changes to Azure Stack. There have been several changes that have come over the last 2 years These are all just released in the monthly update cycle. The resource providers, App Service and SQL MySQL, they have their own updates and they're released separately. And the OEMs release their own firmware switch configuration updates. They're applied in a separate pass, and you would work on that process with the. What happens if it goes wrong? Obviously, in the portal, our philosophy is to give you an indication that something's gone wrong, not just with updates, but everything in general. Give you a way to look at what's gone wrong, and ideally prompt you for a way to fix it. So you can do the same thing for the update runs. You can see whether it's been successful, whether one is currently in progress, and whether it's run, and you can drill down to it. There are logs. They're stored as a JSON file. So if you look at the logs, here's what you'll do. You'll find out where the logs are stored using the Azure Stack command. You'll get the content of the log. It'll be a JSON file, and you can convert it from JSON and read it nicely in PowerShell. So you can see here that there are several steps of a sample update that you can view using PowerShell. Another option is there's a way to convert the JSON file into an HTML file, and you can read it a bit better. So here's an example of a JSON that's been converted. So you can see the steps, the names, whether they're successful or failure, etc. So normally you wouldn't really look at this. As an operator, you're just going to be concerned whether it was successful, whether it's still running, or whether there's been an error. If there's an error, you'd normally retry it. If the retries aren't working, you would open a support case and there would be some troubleshooting. The troubleshooting would involve looking at logs like this. So normally this isn't a monthly task for you. This would really be only an exception wrong with the installation. So here's an example of connecting to the privileged endpoint. So you'd open a session to the privileged endpoint, give it your credentials, and then you're going to run a script against the privileged endpoint to get the Azure Stack log. And then you can slap it out to a file share that's accessible to you. So that's sort of a one-liner to get all the log files related to, in this case, the update that failed. Thank you. That's a summary of the patch and update cycle. As I said, as an operator, the user interface is very simple, but it's nice to understand all the detailed engineering that's happening behind the scenes, and particularly that it's going to take a considerable amount of time that varies depending on how many nodes are in your Azure Stack instance and how busy your Azure Stack scale unit is, because all of that shuffling of the user workloads around will take longer if you have more running virtual machines. So I hope you enjoyed this. You can carry on with the next module after this. Thank you.